So when we begin to look at how do we write the formulas for names and where do they come from, it stems from those charges that we just looked at on the periodic table. Looking at the name of a compound, one of the things we want to do is we want to balance the charges. Anytime two elements react, they react in order to try to make their overall charge 0. And so that's our goal, is to make sure that the charges zero out. We'll begin with some easy ones and we'll make it a little more challenging as we go through. Okay, so we're looking at the name here. I'm given the name sodium chloride. The sodium comes from the left side of the periodic table. It's a cation. It's a metal. And so I know I'm going to have to name it like an ionic compound. And so when we do that, we just name the ion. So I go to the periodic table, I look up sodium. I know sodium has the symbol Na. It's in the first column, so it has a 1 plus charge. I go over to chlorine. Chlorine's in the halogen family, but it's not chlorine anymore, it's chloride. I know the symbol of the chloride ion is 1 minus. So I look at these and say, okay, if sodium's giving up an electron and chloride is gaining an electron, I know that if I have 1/4 to give away and somebody needs a quarter, that I can give a quarter to one other person. So the ratio here really is 1 to 1. So if I look at it, it's going to be sodium 1 plus. I need one of them. I'm just going to put a 1 down in there at the bottom for now. Probably don't need to do that. Chloride is a 1 minus, and I know I need one of those. The mathematics on this is as follows. If I have one thing, one sodium ion that's a 1 plus charge, 1 times 1 is positive 1. Looking at the negative side of this, the anion side of this, I have one thing that's negative 1 charge. So that gives me negative 1. Remember, our goal here is 0. If I take one thing that's positive 1 charge and I add it to one thing that's negative 1 charge, their overall charge comes out to 0. So looking at the ratios here then, it's a 1 to 1 sodium 1 chlorine 1, and by the very fact it's written there, I know it's 1. So the formula for sodium chloride is NaCl. Okay, let's try another one. Going to the next column, magnesium. I know that magnesium is in the alkaline earth metals. And I know that the alkaline earth metals form a 2 plus charge. That means every atom of magnesium gives up 2 electrons. But I'm matching it with chloride here. I know that chloride gains 1 electron. Well, if I have 2/4 and I come across something that needs 1/4, I can give a quarter to that person, but I can also give a quarter to somebody else that needs 1. And if you can see here, I need the 2 negative 1 species to match with the 1 positive 2 species. So it looks like I'm going to need, magnesium has its 2 plus. Each chlorine has its 1 minus, so it looks like I'm going to need 2 of those, which is what it shows here visually. Again, let's make sure that we've balanced our charges correctly. Put a little B1 down here. I have one thing that's 2 positive. 1 times 2 positive is plus 2. 2 times 1 negative is negative 2. If I have something that's positive 2 and I add it to something that's negative 2, again I've balanced my charges to make it 0. And the formula then for magnesium chloride comes out to Mg, and I could put the 1 there. For now I'll do it. You don't, like I said, if it's written, it's understood, it's there. MgCl2 is the formula for the ionic compound magnesium chloride. Now there's a shortcut to this, but you still want to check it with the math. Go back and look at your periodic table. You see that aluminum tends to form a 3+ charge. It loses 3 electrons to become 3+. Chloride, you're starting to see the trend here. Each chloride needs 1-. Well, I could do the math, and I think you can see the trend here that if I have aluminum chloride, I'm going to need 3 chlorides here. A little easier way to do this is what we call the crisscross method. And again, I told you that chemistry is just ratios. If I look at the number that's up here of the charge, that 3, and I bring it down and make it the subscript for my anion, that tells me how many of those things I need. Because what is this? It's just a ratio between the positives and the negatives. And then if I take the number, now I don't want to carry the charge down there because I'm just looking for how many atoms there are. And I'm going to bring that one around this and put it right there. Make that a 1. What's my formula for aluminum chloride? It would come out to AlCl3 using this method of the crisscross. And that works for all ionic compounds. You just need to make sure that you are crossing appropriately and still balancing the charges. Let's check this to make sure that it matches the method that we used up above. I have one thing, one species that's a +3 charge. And so that gives me +3. But I have 3 things that are -1 charge. 3 times -1 gives me -3. +3 plus -3 gives me an overall charge of 0. My formula for aluminum chloride is AlCl3. We're going to try a couple more off of here. Maybe you should try them, and I'll put we'll try the answers in class. See if you can get these 4 on your own. We'll give you the answers in class. No fair Googling them and looking up the answers.